This is part 2 of the care and feeding of programmers addressing application security gaps using HTTP headers. So now, having seen all the directives that are available in CSP, if a programmer were to implement content security policy, what could possibly break inside of their code? Well, the first thing that you need to realize is that any inline JavaScript or inline cascading style sheet calls that you make will be broken. So this is where being disciplined about externally referencing any of your JavaScript or CSS in separate files really pays off. And if this has been a pattern already established in the development of your web app, then implementing CSP is not going to be a challenge. However, if you do have any inline JavaScript functions, even if they're as simple as clearing text boxes, you're going to need to go ahead and take that code, take those functions, place them in their own files, and then externally reference them. Obviously, you'll be referencing the file, but everything's going to hang off of that particular whitelisted domain that you're setting for your CSP. Now, there are lots of other really great HTTP headers that should be used to protect web applications. I'm naming a few of them here, although I could have an entire talk on probably each one of these, particularly when it comes to HSTS, which is the HTTP Strict Transport Security header. This basically ensures that you do not have a lot of mixed content where you have HTTPS with HTTP, and so it ensures that once a transmission is established to be secured, meaning running over HTTPS, that it will not switch back to HTTP, and this is for your protection. There's also an HTTP key penning, which is basically a penning of a digital certificate to be known. And so, as well as H-frame options, an XSS protection, which we're going to see in the demo, content type options, and a no-sniff directive to protect against man in the middle. Now, if you were to take a snapshot to see what the content security policy actually looks like from the client browser perspective, because remember, the policy is actually enforced by the browser. So you could actually take a look at your network. If you use developer tools in any browser, you could see in the network the refusal of foreign scripts from being run inside of your browser because of the content security policy. And it'll tell the directive and explain why particular referenced external scripts are not allowed to run. Now, as I mentioned, the content security policy is enforced by the browser, so it is important that you have browser compatibility. A lot of companies use Internet Explorer, and so realize that according to this chart, IE9 is not supported. So if you're still having users that are on IE9, you'll have to actually wait until that is phased out to be able to use the directives. Now, there are some different directives that are related to content security policy that are made available just for IE. They may have an X in front of the header name, so X content security policy. So you could actually look into those, but to have that consistency across all the browsers, you do want to check this compatibility matrix. Now I've got a quick demo to show you about content security policy in action. When you go to look at the live HTTP headers, particularly if you're using a newer browser, you're going to notice that there's a protection here, and it's identified as XSS Protection 1 Mode Block. And what that's doing is it actually will prevent the execution of any scripts or inline JavaScript, inline style sheets that might be on the page, and also that may be referenced externally, and that's for our own protection. I also wanted to quickly show you from the OWASP website this list of useful HTTP headers. Included in here you will find that XSS protection and how it's an anti-cross-site scripting filter that's been added to many browsers. I also wanted to point out the content security policy. This is a header that can be added as a configuration in your web server and then passed back to the browser. If you'll notice here, it says the content security policy requires careful tuning and precise definition of the policy. If enabled, CSP has significant impact on the way browser renders pages, including inline JavaScript disabled by default. CSP prevents a wide range of attacks, including cross-site scripting and other cross-site injections. One of the last things I wanted to demonstrate is just how many different scripts there are that run within your browser based on any website that you go to. What I have here is a plugin for Chrome that's called Script Safe, and this just is to let you know that because of the content security policy, I'm able to stop these scripts from running in the background as I've gone to just a random website. Just wanted to try to show very quickly what it says here. It says, just looking at one of these scripts, refuse the execution of inline script because it violates the content security policy directive. Okay, and so this is how, if you had a content security policy implemented, this is how it would work for you to protect you against cross-site scripting, as well as the other injection type of attacks that could occur. So now we come to the HTML5 whitelisting, also included in our defensive measures. Of course, we never want to allow any kind of client-side callback functions. This goes back to that JSON padding or that JSON P attack that I referenced earlier in the talk. And so the common lesson here is that anything that you declare on the client side is obviously suspect for tampering by an attacker. So make sure that you keep, if you're going to include anything on the client side, make sure that you do your validation on your server side before execution. And just one other thing, and that is that you can whitelist those callback domains on your server side, as well as any redirects, right? You want to make sure that any redirects are always validated on the server side. In a lot of HTML5 technologies that are used now, particularly ones like React.js, there is actually a client-side version and then a server-side version. So that's an isomorphic language. And so take advantage of that to place your validation on that server side, and you also get a performance improvement as well. It works for two benefits. Now, the references that I would point you to include a Black Hat talk that I had mentioned earlier in Part 1, as well as a DEF CON 21 talk on how to use CSP to stop cross-site scripting.